Hi, hello, welcome back to Learn with Ishore. Today we're gonna discuss one of the stack problem in late code. That's problem number 496 in late code. Let's see what they are looking for. They mentioned the next greater element of some element x in an array is the first greater element that is to the right of the x in the same array, which means they are trying to convey that if we have an array like this and it has elements 1 2 3, if we are at this element, they are looking what is the next immediate greater element that is corresponding to this element, which means what is the next greater element. That's what they are looking for. So I think that's a clear what's that statement um, states the next greater element of the some element x in an array, some element x in an array, some element x in an array is an in an array is the first greater element that is to right of x in the same array. If this is x element, what is the next greater element? What is the next greater element? That's what they are looking for. For this, what they have done, you are given two distinct zero indexed integer arrays. We have two arrays and it's named as nums1 and nums2, where nums1 is a subset of nums2. Okay, we have a two arrays, uh, like for example 1 to 3. Let's take for example 1 2 3 is one array, and probably 2 and 3 is a subset array, and this is nums1 and this is nums2. Nums1 is subset of nums2. That's what they have given. And in next nums1 and nums2, where nums1 is a subset of nums2. For each 0 less than I less than nums1 dot length, find the index j such that nums of I equals to nums2 of j is okay. We'll use this statement further in our condition and determine the next greater element of nums2 of j in nums2. Okay, and if there is no next greater element, then answer the for this query is -1. Return answer of length such that answer of I is the next greater element described below. Okay, they are asking in a way like this is a subset of nums2, like nums1 is a subset of nums2, and we are at this element of at nums1 corresponding to this element in nums2. What is the next greater element? For this 3 is next greater element. For this there is no next greater element here, so the answer might be 1. This how it works. The answer should look like 3 and -1. That's what they are looking for. Answer array of length of nums1. So length of nums1 is 2 and length of answer is 2. That's what they are looking for. Even if we look at the example 1, they are stating nums1 equals to 4 1 2 4. There's a 4 1 2 is a subset. Since 4 after 4 it doesn't have any greater element, so it's a -1. And for 1 the next greater element is 3, so 3 is a element. And for 2 there is no next greater element, so -1. So -1. That's how it there. I mean, that's what they are looking for. I hope it was clear. Let's see how we can solve. Okay, I think the problem was clear as far as the given question. I hope you guys will understand. Let's see one of the brute force approach first. What will be the most naive approach? Brute force approach. We'll write a function where we can call as def next greater element, where we'll pass nums1 and nums2 are two arrays. We'll find the length of nums1, length of nums1, and m is equal to length of nums2, what they stated. So we know that we need to figure out the we'll take the same example, that's a 1 3 4 2 given array. The given array is, what was the given two arrays? Given two arrays, nums1 is equal to 412 and nums2 is equal to 1342 1342. First we'll figure out what is the next greater element for nums2. What is the next greater element for nums2? For that, definitely we need a stack, requirements. So we use the stack. We need a stack, and we also need a temporary array to store the answers. How we can reach that? We'll do that. So we'll run a for loop for I in range 0 to m, since we are doing for nums2 whose length is 4, that's m whose length is 4, so 0 to m. And what we were doing, we need, as I mentioned, we need a stack. We'll take a stack, and as well as we'll take a temporary array of size m. So we have array and a stack as well. So we'll try to do things like, at first our stack is empty. So yeah, at first our stack is empty, right? So we'll try to solve what happens if we have stack. If while stack is true, the given if stack has a elements, let's take at first instance the stack was empty, so we'll append we'll come from n. So the next greater element, right? If it is a greater element, then we'll append it. If it is a smaller element, we'll pop it. So that's how it works, and I'll tell you in detail while going through, and we'll do some dry run as well. So or else we'll do the dry run first. So let's take a empty stack, and we'll take an temporary array, and we know that the array is so the array is 1 3 4 2, right? We are at here. At first the stack is empty, so we'll push this stack, and what is that element? Array of I 1 2 3 4, that's 3. It doesn't have any element after that. That means there is no greater element. In the question they mention, if there is no greater element, if there is no next greater element, then it should be -1, right? So there is no next greater element after this 2, so we'll consider this as -1. We can make that a temporary of I equals to -1, this, since it is a temporary array. And we came here, we saw that, is this a smaller or bigger? When we are here, we'll check that st of -1 gives the last element in the stack. when we compare these element, the last element, that's a 2 is smaller than 4. What we were looking for, we were looking for greater element. Since it's just a smaller element, will pop out, will pop out, will pop out. After popping the stack, does it have any element? No. If it does not have any element, then what is the condition we need to consider as -1? That's what they are looking for in the question, so we are at it. Okay, and then what we will do next, we are going to compare these two numbers. As a result, we need to append 4 to the stack. We need to append 4 to the stack. Okay, and then we were at here 3. Now what we were looking, 3 or 4, what is the next greater element? When we are at 3 and we were looking at laser stack, this is 4, and we were looking at nums2 of I, that is a 3. 4 is greater than 3. As a result, what they mention, they are looking that for this element they need the next greater elements. That means 4 is next greater element. Is it right? Yeah. And then we have appended 3, and we are here at this moment, and again at the stack st of -1 and nums2 of I. At this moment, st of -1 is the last appended element is 3. It has a 3, and we are at nums of I, that's a 1. 3 is greater than 1. As a result, 3 is the next greater element of 1, and that's it. This is what if we do the next greater element for the nums2. And after getting this nums2, what we can do, we can run another for loop, another for loop, and with respect to whenever we see nums1 of I equals to nums2 of j, with respect to that corresponding I, we'll take the element from here, and we will try to assign that to answer array. As a result, we'll get the resultant array. We'll try to do that, how it works. Now we have a temporary array. I can say that's a temporary array. If 3, 4, -1, -1, whose indexes are 0, 1, 2, 3, and we have nums2, that is 1, 3, 4, 2, 1, 3, 4, 2, and we also have nums1, that is, I guess 4, 1, 2. Yep, that is 4, 1, 2 is 0, 1, 2, 3, 0, 1, 2, 3. Here we need for the length of nums1, so we were clear that we need to run the outer for loop for I in range 0 to n. The n is like something at the length of nums1, so that's what it's clear. And when it comes to inside, we need to run the another loop for j, for this one, for j in range of 0 to m. Here we'll write the condition if array of I, that's, I can say that's nums of I, sorry, that's my bad. If nums of I equals to nums2 of j, which means we were at here 4, and here at 3, when these two elements are equals to each other, then what we were trying to do is we'll take another element like j is equal to k, and we'll try to run another the another loop for equals to I. So no, not even, this is not necessary actually. Yeah, we can we can solve in different way. Let's see how it works. If they both are equal, we'll take another one. If they both are equal, we have that, we know the j value means their index value. So we can take answer of I is at 0. That's a I is 0, right? Here I is 0 at first index. Now j is at index 2. J is at index 2. If they both are equal, now we know answer of I equals to, we have a temporary of a which is holding its next greater element. Next greater element is, what is the next greater element of 4 at here? What is the next greater element at 4? So we can assign that temporary of j. Temporary of j. Now if we consider an answer array, it has -1 at 0 since I is at 0, and after that we'll break that loop, and next time we'll come for 1, and we were here and now we are looking for 1 is at 0 if they both are equal, and we'll check for what is the at index 0, what is the element, that is 3. So we consider 3, and next we go for 2, this time this 2, and we start at 0, and the moment when we reach m-1 here, they both are equal. So I is 2 and temporary j is m-1, that's a 3. What is the value of temporary? 3. So that's a -1, so we'll consider -1. So once that's break, and since it doesn't have any extra more length, the loop will fail. Since it reaches its length, and we'll try to return answer. That's what it is. Probably we can try it. We can try this in we'll try to code it as well. Let's try to solve the problem what we were looking for. Class solution, we'll initiate a class, and initiate a class. We'll write a function that's next greater element, and this next greater element ng, and we need two arrays, that's nums1 and nums2, and what we gonna do is something, we need the length of them. So n is equal to length of nums1, and m equals to length of nums2. So we need to figure out the next greater element of this length to out, right? So we need a stack, and we need a temporary array as well, and and we'll run a for loop for I in range m-1 to -1, that's we need till 0 on, right? Till 0, so -1, and while st is true, while if we have st and st of -1 greater than nums1 of I, if st of okay, we can write this way, if st of, sorry, that's my bad, if st of -1 less than this, and we need to pop from the
stack, that's clear. And else if it is not that case, we need to consider that into temporary array, temporary of I. So for temporary of I as well, we need something none stadium length of m I equals to st of -1. That's a greater element, and we also need to append, right? St of append so one of I as well. And once we done that, okay, we are good to go. And what if there is no st, if no if there is, I mean if the stack is empty, so we need to consider that again. And so temporary of I equals to -1, and we need to append. So as a result, we need to write this and -1 of I. So that's my bad. That's it, I guess. Well, yeah. So this is good. So now we have an temporary array for values. So we'll try to run the loop again, so that now we'll do things. Yeah, for I in range, for I in range 0 to n. Again we need to run, right? For j in range, and j in range 0 to m, the moment if okay, if nums1 of I equals to nums2 of j, nums2 of j, what happens? Okay, it's my bad, like I was missing syntaxes constantly, it's not good. Okay, what happens? We have an answer. No, we haven't considered that answer. We'll initiate an answer array of size none or 0, and there should be length of n. Yep, it should be length of n. Answer of I equals to temporary array of j. Yeah, temporary array of j, and we'll break it. Yeah, and probably we'll return this return answer, and we'll try to do the try run. Object solution, sorry, and ng, and we need nums1 and nums2, right? Okay, and what will be my nums1 is equal to array of 412, right? If I'm correct, yeah, 412, and my nums2 will be 1342. Yep, 1342. We'll try to do the try run. If there is any errors, yep, nums1. Okay, st dot nums of I list index if m -1 if not st of I. Oh, that's pretty strange. St dot append y starts from m -1 and ends till 0. If not st, temp of I nums1 of I. Let's see why it was failing. Nums1, and it has a stack, empty stack, and while st, if not st, temp of I -1, Sounds one of I. What will be the I is 333. Probably Amazon of I. Sorry, that's my bad. This should be nums 2. This should be nums 2. Yep. This should be nums 2. Now I think we were good to go. Okay, again. Once we set this, it should break. Yep. Okay. We got it. -1, 3, and -1. Yep, that's perfect. So it was working well. We'll try to run in LeetCode. Let's see whether it perform or it's not. Yes, probably this may fail because it might not be the optimal solution. No, it was okay, but let's see what is the time complexity. Time complex, I haven't explained time complexity. It will take n into m. Yep, it's big of m plus n. Which complexity is runtime? And what is the space complexity? M plus n. Probably it was giving wrong time and speed, wrong time complexity actually. Let me explain how. When we were here, probably this might not be the optimal solution, but yes, when we were here for this one, yeah, for this one we need m time complexity big of m, that's approximately, and for this loop we need time complexity of big of n, and for this time complexity at worst case for this one at I is equal to 2, it has to run till m minus 1, so time complexity might be big of m. So I can take big of n plus big of m plus big of n into m. So the overall time complexity might be big of m plus n into m. This might be the big of time complexity. I'm sure that there might be optimal solution. We'll see it in next video. We'll see it in next upcoming. If not, why not? We'll try to solve it now itself. So we can write yeah, I'm getting idea in a way. I was thinking to use of stack and hash map combination. hash map combination. Let's see how we can do that. So we know that n is equal to, okay, this not good color, we'll make it black, okay. That's n is equal to length of nums1 and m is equal to length of nums2. We'll take a stack and we'll take a hash map. That hash map is equal to this, and what I was trying to do that, like, eventually you'll understand once I write, if I write the function for I in range m minus 1 to 0. We'll do the same function, and while stack is true, and again this is true, st of minus 1 is, if st of minus 1 less than, that's us, if there's something element that is less than the I value, then we'll pop them, else we'll append them. Else what we can do, we'll append them into stacks. So this time we'll try to do in a way where temp is like a hash map, instead of this, we'll take hash map of nums2 of I equals to st of minus 1. What it does, in a way, this is stack, and this is my hash map, that is hash map. In my hash map, at first I'll think that's my nums2 is equal to 1 3 4 2, right? So let me write the if function as well. If not st, then you'll understand. If not st, and we'll try to do hash map of nums2 of I equals to minus 1. Yeah, here it is minus 1, and we'll st dot append nums2 of I. That's what it goes. So at first it is stack empty. We'll try to nums2 of append my append 2, that's a 2 to my stack, 2 to my stack, and in that hash map, it's like a key and a value pair, right? For the key nums2 of I, what is the nums2 of I? That's a 2. For 2, what we are assigning, minus 1, okay. And for the next iteration, I was here, and we'll check that function, is that less than? No. Yes, it is less than. So we'll pop this, we'll pop here, and what we were doing, and again st dot append nums2 of I, that's a, and we'll break it as well in order to break the loop. What we were doing here, again, since we were popped it, and the stack will be empty, and again for 4 it will be minus 1. Now the loop is here, I mean the I is here 3, and in stack we have 4, and st of minus 1. Does 4 is less than 3? No, right? So we'll come here and we'll take for 3, 4 is the next greater element, and we'll insert 3, okay, into the stack. Now we were here, and we'll come here, and for 1, 3 is smaller, no, 3 is a greater element, so we'll come here, and for 1 3 is next greater element, and loop will break. In the next for loop, will for I in range 0 to n, that's for 0 to 2, 0 to 2, what happens if now we have hash map, right? If nums1 of I in if nums1 of I in I, that's a key, if nums1 of I, that's a key in h map, that is in h map, we'll try to do answer of I equals to h map of nums1 of I, which means hash map of 1, hash map have 1, so hash map of 1, its corresponding key value will assign to corresponding I value. If my nums1 is a 4, it has a 4 in hash map, and corresponding, I mean 4 is a key here and -1 is a value, corresponding value is -1. As a result, we'll get the answer array as for 4 1 2, for 4 1 2 -1, and for 1 3 is the value, we'll get the 3, and for 2 -1, for 2 -1. This will be the optimal solution, whereas it will run big of n times, and most probably we can consider it will run big of m times, so the time complexity will be big of n plus m, and the space complexity will be like, for answer array it will be the big of n, and obviously we don't require the stack, and the temporary array, if we make it as, if we assign to none, so they don't require us, they don't consume any space, so we can consider this is big of n. You can try this, definitely this might be the optimal approach when compared to big of n plus m into n, and big of n plus m is a smaller, so when compared to this is a smaller, so this might be the optimal approach. Yeah, optimal approach.